Hi everyone, today we're going to be talking about topic 9.6, free energy of dissolution. As a reminder of our few rules of spontaneity, if delta H is less than 0 and delta S is greater than 0, the reaction proceeds all the time. If delta H is greater than 0 and delta S is also greater than 0, then the reaction proceeds at high temperatures if delta H is less than 0 and delta S is also less than 0, then the reaction proceeds at low temperatures and finally, if delta H is greater than 0 and delta S is less than 0, then the reaction will not proceed. And as a reminder of what is preferred and not preferred, on the preferred conditions are that delta H is less than 0, in other words, exothermic, and delta S is greater than 0. That's preferred. Unpreferred, or really unfavorable conditions, are that delta H is greater than 0, in other words, it needs energy, and that delta S is less than 0. In other words, it is becoming more ordered. In any situation, right, those are going to be not preferred. Of course, you notice in the situation where both of them are preferred, delta H is less than 0 and delta S is greater than 0, the reaction always goes. If one of them is not preferred, then you have either high or low temperature, and if both of them are not preferred, then the reaction does not happen. Now, in the context of making a solution, there are three different processes that can occur. In the first one, the intermolecular forces between the solvent particles are overcome. As a reminder, the solvent is what dissolves the solute. When you're dissolving a salt, that's typically water. Right, and so in one case, right, you have the intermolecular forces of the solvent particles are overcome. In other words, for water, right, the hydrogen bonds break up. In this case, delta H is positive, or it's greater than 0, and delta S is positive because you are making a less ordered system. The second process that occurs is that the intermolecular forces between the solute particles are overcome. And so, for example, in a salt, right, these are the ionic bonds that hold together the salts themselves and also just the negative / positive interactions. In other words, the electrostatic interactions that hold together a salt. In that case, delta H is positive because you need energy to break apart the salt, and delta S is positive because you are physically breaking the salt up, and it's becoming more disordered. The third process that occurs in a solution form is that the intermolecular forces between the solvent and the solute particles must reform. And so what you're doing here is you're essentially making bonds. Because of that, delta H is negative because you always release energy when you make a bond. And delta S is negative because you become more ordered. So if we think back to one of the labs that we did where we did the enthalpy of dissolution, right, those first two steps, breaking up all the IMFs, that always requires energy, but it also makes things less ordered. And so your entropy is going to go up. Both those will go up. But then that final step that's exothermic will also make it a more ordered system, which is not preferred. So let's look at this little example problem here, which says which solution will have a greater entropy, in other words, delta S, with all other factors remaining equal. And so we're essentially looking at two different salts here. One is cobalt hydroxide, the other one is beryllium hydroxide, and we're given KSP for each of them. If you're given a KSP, the reaction that's essentially happening here for cobalt hydroxide is going to be this. Cobalt hydroxide is going to dissociate to make cobalt 2 plus and 2 OH minus, and KSP is 5.92 times 10 to the minus 15. The second one is beryllium hydroxide. BeOH2 is going to make Be2 plus, beryllium, and 2 OH minus, and this KSP value is 6.92 times 10 to the minus 22. What these values tell you is this one is greater, and so this reaction is more preferred. In that first reaction with COOH2, more ions dissolve, therefore more particles are in solution, thus delta S is greater. So there are problems like this where you're essentially just given a situation where either something is dissolving or you're making a new solution, or a reaction is happening, and you're asked to think about whether or not delta H or delta S is going to be greater, less than, or equal to a certain other process. And the way you look at that is essentially by looking at K, right? If K is bigger here, that means that this forward reaction is preferred. Of course, here I should have added as well, right, that these are aqueous because you're dissolving it. And if you make more aqueous species, that means delta S is going up. And so in a question like this, right, this is how you would answer that question. I want to look at this one example problem here to kind of show what a free energy dissolution problem will look like on AP Classroom. And so in here we have two different diagrams, one by student 1 and one by student 2, and we're essentially asked which one is most accurate. So it says they prepare an aqueous solution of LiCl and measure the properties as shown in the table above. I'm not actually giving you the table just because that table isn't really necessary for a problem like this. Both students observed that the LiCl readily dissolves in H2O, and if something dissolves in H2O, that means essentially the reaction that I have here is this. LiCl solid makes Li plus and Cl minus, and we're told it readily dissolves, and so this equilibrium is really to the right. It says they drew particle diagrams to explain the changes in enthalpy and entropy of the dissolution of LiCl based on the results and observations. And then again, we're asked which one is the most accurate based on these diagrams. If you look here, diagram 1 has the particles on their own, whereas diagram 2 shows it still together. And so if we look here, A and B says that the diagram by student 1 is most accurate. C and D says the diagram by student 2 is most accurate. And so immediately the first thing we should do here is try and figure out which one is most accurate based on the picture. Remember, we're told it readily dissolves. And so we should not have LiCl together in solution. It should be Li plus and Cl minus on their own. So I should have this. If we look at our diagrams, this one has them together. And so it cannot be this diagram. And so C and D can't be the answers there. So answer choice A says that when LiCl dissolves in water, it dissociates into Li plus and Cl minus. That is true, which causes an increase in entropy. That makes sense because we're going from one particle to two particles. And so delta S would be greater than 0. That's exactly what that says. B says that when LiCl dissolves in water, it dissociates into Li plus and Cl minus, which is true, indicating that the dissolution of LiCl is exothermic. This is not necessarily true because remember, to break up LiCl, delta H must be positive. Now, when you actually dissolve it and remake the bonds between the water and the LiCl, that can be negative. And so this one in particular, we don't necessarily know because we don't have enough information. And so we can't say B is the answer. And therefore, A is the only one that this diagram is actually describing, right? We can see that it breaks up from one particle into two. Therefore, entropy must increase. And so the most accurate answer here would be A. We'll discuss this more in class, but for now, that's all. Thanks, guys.